Hey guys, we are working through section 3.3, problem number 21 of James Stewart's Calculus Early Transcendentals Edition. Alright guys, so this problem we're doing the product rule. There's the important thing to notice here is that there's three terms. There are two multiplications here. So the first thing to figure out is what this question is asking for. It's just asking for the derivative of f. And so two things that I'm going to mention is that there's a multiplication between the cos and the theta, and then between the cos and the sine. So there's actually three terms, theta, cos theta, sine theta. So we basically need to use an extended power rule. So we need to know the derivative of sine and cos to begin with. You should be able to locate it on a formula sheet hopefully, or it's the start of the chapter. Ideally you want to memorize these. So the derivative of sine theta is just cos theta, and the derivative of cos theta is negative sine theta. And finally, the derivative of theta, well, it's just a variable. And if you think about the derivative of x equals 1, the derivative of theta, because it's a variable, it's just going to be equal to 1. Okay, if someone is really new, or they're very bad at calculus, or they can't keep things straight in their head very well, I recommend making a table like this. So there's going to be three terms as we went over earlier. Your first term is going to be the theta, your second term is going to be the cos, and your third term is going to be the sine. So on the first line we have your original functions. On the second line it says derivatives, so we're going to take the derivatives of all of these. The derivative of theta is 1. The derivative of cos, negative sine. The derivative of sine is just cos. So now we have our originals and our derivatives. So next step is we throw it into our formula. Okay, so our formula is this. Basically we have this little I hat thing that's jumping from the g to the h to the I in each term, and it's just the three things multiplied by each other with a little space in between. So it's a pretty easy formula to memorize. It's basically the first term times the second term times the third term written 3 times in a row, and the hat starts on the g in the first term, jumps to the I in the second term, or sorry, the h in the second term, jumps to the I in the third. You can think of that hat as going jump, jump with each term. So starting here, we have g theta, or g prime of theta, which so we look on the first term, and we look at the derivative, and we see, oh, it's 1. And then we have h left alone, which is just the original for the second is cos, the original for the third is sine, and then we jump to second term. Here we have the first term is the original, theta, the second term is the derivative, which is negative sine, and the third term is still original again, which is just sine theta. And then finally for the third term, we have the original left alone, which is theta, the middle one left alone, which is cos theta, and finally the third one derived, which is cos theta. Now we have to start to simplify, which is kind of the tricky part. This textbook requires you to pull two trig identities, basically out of your memory from grade 10, or your butt, depending on how you want to look at it. And so with this one, we have a theta, and we have a theta in front of both these terms, so you can factor it out. So all I've done is I've just moved the theta in front of both terms outside of the brackets here. And if you look, one other thing which you're going to notice is that you have a sine theta and a sine theta, and you have a cos theta and a cos theta, which means we can write this as cos squared theta, and we can write this as sine squared theta. So that's my next step. I also rearranged the sine squared theta to be in front, because cos squared theta minus sine squared theta is a trig identity. So I'm basically going to replace this trig identity here with the equivalent double sine angle, which is cos 2 times theta. And that's what I do on this next line. I've just replaced what was in the brackets with this cos 2 sine theta, and then I'm just removing the brackets on this next line to clean it up a little bit. And to me, this looks pretty simple. This looks like a good answer. I would have been happy here if I was your teacher, but for whatever reason the textbook goes, oh, let's pull another identity out. And so basically cos theta times sine theta, or if you switch around the other way, sine theta times cos theta, is also a double angle identity, where you can go 1/2 sine 2 theta. So all I'm doing is I'm just replacing this with this, because it's a known trig identity, and this is the simplest you can make it. Personally, I like the line above, and I think that's far enough, but if you are really happy to do a lot of trig identities, you can try to memorize this one, keep in the back sheet of your pocket, see if it shows up on the formula sheet. And yeah, that's how you solve these problems. If you guys like the solution, I have another 23 or 24 videos from this section in a little playlist. It should show up somewhere on the screen here. You can click on it, or you can look at the recommended video. Anyways, have a good day, guys, and take care. Good luck.